Good evening, ladies and gentlemen. We got a Magna here, 2002 model, I believe. Yeah, it's just the 3.6 liter V6, right? Car came in with the problem of stalling. So car cranks, starts, and then it shuts down immediately. But if you hold the revs up, the car stays running. As soon as it drops to idle situation, the car stalls. You can start it again, continue to do that all day long, and continue to do it. Now, I cannot really show you that because today, we did a little bit other day, but today the car is running, no problem. So I would say there's an intermittent issue with the mass airflow sensor. That's where we were last time we did the video. There was a mass airflow sensor fault code as well. So while I was touching it or banging on it, whatever, the car is running now. So I can't really show you the problem, but we can get into the detail of how can we tackle this kind of problem. If it was the permanent fault, we can do the checkings on the wiring, and I'll show you. There's 7 wires on that plug right there on the mass airflow sensor. I'll show you all the function and everything on that mass airflow sensor. All right. So I'll show you quickly that the car does start. Okay. All right. I'm just gonna get to the ignition. The car runs, no problem. So I can't fault it anymore. So I can't show you that problem. Okay. But let's get into the detail just in case next time you got a similar situation, we can tackle this, in detail. Okay, so now this type of sensor are used on a lot of older Mitsubishis. Your Lancer, I've seen them on Pajero, Triton, 4 cylinders V6, Mitsubishi Magnus. They all got the similar setup, similar looking mass airflow sensor. There may be a little bit of variation there, but they all look the same. Okay, so this one can cover pretty much the older Mitsubishi models and everything. So let's get into it. So I'm doing it live. So if anyone's joining, welcome. I can see my friend Joshua. Welcome, Josh. Let's get into it. Okay, I'll quickly show you the fault code. Other day we were seeing, right? So that's the fault code. I hope the internet is good today. The other day the internet wasn't very good, so I couldn't do the full video. So we missed that problem and all that. So today I'm gonna sort of continue that video. So we got the scan tool here. We have airflow sensor, right? So this is the trouble codes. So AFS code 12. So our airflow sensor. So let's go to the live data. That's where we were other day. Wiring diagram, yes, I'll show you the wiring diagram, everything, Josh, in a minute. Let me just go through this quickly, just the introduction, so anyone watching today or in the future knows where we're at. So this is a very, very slow communication because it's older car maybe, right? So if you go at the very bottom, you see a VAF sensor, which is your airflow sensor, right? So I'm not getting any data. Let me go back and restart again. So live data. Yeah, it's a very, very slow communication. So let's go all the way down. We're only interested on VAF sensor. We will talk about that VAF reset signal if you want later, right? It's this one, but I'm not too worried about it just yet. But on the VAF sensor, we got 0 hertz. So when you see hertz, it's a frequency type airflow meter, right? So what that means is it's probably going to be a digital signal. It's not an analog signal. So we can get into it in a minute. Now maybe on the board I'll show you what is a digital, what is an analog, what you need to see, something like that. So we got a VAF sensor 0 hertz. Let me start the car and then we can have a bit of idea, okay, what kind of hertz we're gonna see on this type of mass airflow sensor on Mitsubishi. So let's start it up. Okay, so we got 56, 50, 43. So 43, 50, 50 hertz. Okay, that's when it's at idle. So I'm just gonna reach out and rev the car a little bit and you can see, I'll just use the accelerator cable here. So you can see that hertz is going up. So that more the numbers, more the airflow is. That's how the computer knows, I believe, right? So let's turn it off. Let's turn the car back on so we'll have some kind of communication going here on the live data. So from here, where do we go next? So Joshua is requesting for a wiring diagram. Okay, let's look at the wiring diagram now. Just before I go, Joshua, is my video clear? Is the audio, everything's clear there? If it's okay, just give me an okay, brother. I'm doing it all live, so I don't know what's the other end of the internet gonna look like on YouTube. Hopefully the internet is good today. Ruben, hey Ruben, how you doing, brother? Ruben is on the chat as well. It's good. Okay, thank you so much. All right, let's get into our wiring diagram like Joshua requested. So let's go wiring diagram. I'm just gonna pull up my wiring diagram here. Okay, so let's go. I actually already have it open from the other day. So this is the wiring diagram right here. So which one is our mass airflow sensor? This one is my mass airflow sensor. Okay, so this is the wiring diagram. Everyone can see this. I'll just zoom it in a little bit more. So right here, this is my wiring diagram. Okay, I'll just let you look at the wiring diagram and maybe we go through a couple of questions here, questions and answers, see if everyone looking at it knows what they're looking at. Okay, here's the wiring diagram, right? So it's a little bit of complicated wiring diagram. You got multiple components in that airflow meter. I'm using auto data. So on the auto data, I got air intake temperature sensor, where I'm highlighting right now, right? We also have barrel pressure sensor, barometric barrel sensor, right? And we also have a VAF, volume airflow sensor. So this consists of 3 components looking at the wiring diagram. We got 1, 2, 3, 4, 5, 6, 7 wires going into it, all different colors, all that, but it doesn't really tell us what is what. So can someone tell me what is what just by looking at it? Okay, so it's a little bit hard to do interaction while he's on the chat, I believe, right? So let me just continue. If you got any question, you can just put it on the chat and then I'll try to answer it. Okay, so there's 3 components here. So basically, this red wire and the black wire is going to be your earth and the power, and they are shared between multiple other sensors and actuators. You can see it's shared here and everywhere. Also, the red one's going to be my power feed. How do I know? Because if I follow that red wire, you'll see it'll go to an engine control relay, and it's shared that power feed to everything. Injectors, you got, multiple sensors and actuators it feeds that power in. Also, our mass airflow sensor has that power feed as well. So we're going to have a power feed, 12-volt source. We're going to have earth. And the rest of the wiring, we don't know, because if you follow this green wire, it goes straight to pin number 19 on the engine control module. So we don't know what it is. We got this red wire, goes computer pin 72. We don't know what that is either. All these other wires, we don't know what that is, but we can probably identify it without those information. And I'll probably try to show you how. Joshua said 4 12-volt, 7 signal, 5 5-volt. I am lost there, Josh. What are you trying to say? So number 4 is 12. Okay, I see what you're saying. Number 4 on that airflow meter is 12-volt, which is correct. That's power supply. And we got number 7 is our signal. Signal for which sensor? There's 3 sensors in that box, in that airflow meter. Probably some kind of signal, but we'll find out. And then we got number 5, according to Joshua, is a 5-volt. No, Josh, 5-volt, or number 5 is earth. As you can see, it's shared between everything here. Number 5, the black wire is shared to throttle position sensor. It's also shared to engine coolant temperature sensor. And it's also shared with the oxygen sensor, and then it's gonna go to our computer. So the computer is supplying that earth to all the sensors. So I know black is my earth on this car. So number 6 is air temperature signal. Number 6 is air temperature signal. Yeah, number 6 looks like an air temperature signal. We can see a little bit of an inside circuit here of the airflow meter, but that doesn't always mean it's accurate. You know, sometimes they don't like to show you exactly what's inside the sensor. It could be true, it could not be true. We'll see about that. We'll see if that's a true statement there. Number 6, so red and the blue, we think could be a temperature sensor. So air temperature sensor, right? Now, what else we got? What else we got? One is 5. 1 is 5. I don't know what you're trying to say there, Josh. 1 is 5. Okay, I see what you're saying. So 1, pin number 1, green, and the yellow, looks like a yellow, GNGE. So GN means green, GE means yellow a lot of the time for auto data only. Other manufacturer will call it different abbreviation for those colors. So on auto data, I know GE means yellow. So green, yellow is 5-volt. Possible because it is also sharing with the throttle position sensor, right? So it could be that 5-volt reference voltage is shared. That's definitely true. Could be true. Okay, so let me take you to the board and then we'll discuss about it. Let me zoom it right into that sensor too, so we could see a little bit better. So on that sensor, you can see there's a big connector. And you can see there is 7 wires. Those wiring does look and match our wiring diagram on the auto data. So which is good. Not always they give you accurate information, right? So let me take you to the board and let's break it down. Because like I said, there is definitely 3 different sensors on that car, right? So let's break it down. All right, so let me go to the board. and then we'll break it down. Okay, so hopefully everyone can see my board, what I'm doing, what I'm writing. If you can't see it, just let me know in the chat. So we're dealing with 7 wires. So 7 wires, we got all different colors. I don't really necessarily care about colors a lot of the time when I'm doing diagnosis, right? So we already talked about there's 2 wires, red and black. So the red and black is going to be my 12 volt, let's say battery voltage, and this is going to be my earth. We know that, right? So how many wires does usually an airflow sensor need to operate? Let's say if there was no other sensor attached to it, like in this case, pressure sensor, barrel pressure sensor, and temperature sensor. If there was only airflow sensor, how many wires do we need? We need 3 wires to operate most of the time. Okay, there's many different types of mass airflow sensor, but most of the time you need 3 wires. So you need power, earth, and a signal, right? So signal. So one of them 7 wires going to be my signal for the airflow sensor going to the ECU, right? And like we said, we saw HZ, which is hertz, which is going to be our frequency style mass airflow sensor, means the signal going to be a digital signal, not an analog signal. So I'll show you the difference between digital and analog. So analog signal usually just go from 0 to whatever voltage. Let's say if it's a 0.5 voltage signal, when the engine is idling, let's say it's about 1 volt. When you rev the car, it's going to go up. This is what you're going to see on the scope if you put a scope. So the voltage is going to go up as you're revving the car. And when it comes down to idle, it's going to come down, whatever voltage is idle. So that's your analog signal. So as you're revving the car up and down, it's going to go up and down, right? Between, let's say if it's a 0.5 volt signal, 0.5. If it's a 0.12 volt signal, 0.12, up and down like that. Whatever the voltage range on that sensor, on that particular model is, okay? So that's my analog signal, okay? This is my analog, L-O-G-U-E, analog signal. So now, what is the digital signal? Okay, I'll just do that here. So digital signal going to be square wave. Okay, this is my digital signal. So the voltage level doesn't change. So minimum and maximum on the digital signal, the voltage level doesn't change. You rev the car, you idle it doesn't change. What's gonna change is the frequency. It's how tighter is the signal is. So let's say if you're idling like this, and if you rev the car up, let's say 2,000, 3,000 RPM, all it's gonna do is this is going to make that square wave tighter, quicker, right? That's all it's gonna change. So that's our digital type signal. And then computer measures the frequency and knows how much airflow is coming through that sensor. So that's how it works. So this is the type of sensor we're going to see on this car, because we know from where? From the scan tool, because we saw hertz on our live data, right? HZ. Okay. So if we were to see a voltage, let's say most of the time, if we were to see a 0.5 volt range, right, on the scan tool, and then as you're revving it, the voltage is going up or down, usually that's an analog type signal. And hertz on the live data means a digital type signal, okay? All right, so I'll just wipe that out the board. So that's for my airflow AFS, airflow sensor. We got 3 wires, 3 wires already out of that 7 wires going to use for the airflow sensor. Now let's talk about the other sensor they had was a air intake temperature sensor, right? So inlet air temperature sensor, meaning the temperature of the air going towards the engine, right? Entering the engine. So we did discuss about this few before too, and on my temperature sensor, videos, you see that all the time. All temperature sensor works the same, doesn't matter coolant temperature sensor or intake air temperature sensor. So the principle is exactly the same. So what we're gonna need on the temperature sensor is two wires, right? Every coolant temperature sensor has two wires. So does the intake air temperature sensor. So we're gonna need what? Let's say on a temperature sensor, we're gonna need two wires, and one going to be my what? 5-volt reference, right? And the other one's going to be my what? Ground, earth, whatever you want to call it, ground, right? But let me get to that later before I say that. And we got the third sensor, which is going to be my baro sensor. So what does a baro sensor needs to operate? Okay, so we got a baro sensor now, the third one. So what does a baro needs to operate? So it needs 1, 2, 3. I'll just give you a hint. I'll just check my chat and everything going good here or not. Okay, looks like my video is good, audio is good, chat's going good. Josh said 3. Ruben, if you're on the chat, you can join in too. Matt, hello, brother. Matt's welcome, Matt. What makes the voltage go in and down? In and down on a digital sensor. You mean up and down. So basically on a digital sensor, it is actually a computer on its own. So they have their own way of doing the sending the signal out. So computer makes its own thing. So basically the sensor part does its job, measures the airflow however it wants to measure the airflow, and the computer does its calculation to send out the frequency to the engine. So we don't know the detail how it works obviously inside, but usually it is a computer on its own. Okay, so we are down to our baro sensor. So how many wires a baro sensor need to operate? Can anyone tell me on the chat? Excuse me. So baro sensor. There are many types of baro sensor, right? There's no one type or two types. There's many types of baro sensor. But on automotive, I've seen most of the time they use, most of the time one type, which is same like the pressure sensor. Okay, they usually use that sensor, but there could be other cars with two wires and all that stuff. But majority of the time, you're gonna see 3 wires on the baro sensor. The same way you test the manifold pressure sensor, the same way you test the baro sensor. Okay, so we're gonna need, like a pressure sensor, we're gonna need 3 wires for baro sensor, right? So I'm gonna go and talk about it, what those 3 wires are now. So we're going to need a 5-volt reference voltage, right? And then we're going to need a ground, earth, and we're going to need a signal, or sometimes you'll have a bias, sometimes it doesn't. Okay? So you're gonna need what? 5, 0, 5, sometimes or 0. And I know this car doesn't have a bias voltage of 5, so you're probably only gonna see 0, 0, 5 on this barrel part of that sensor. Okay, so like I said, treat the barrel sensor exactly like the pressure sensor. There's no difference. Okay, so and we've talked about it in the past. So let's not spend too much time here. Now let's count the numbers of wires. So we got 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 wires here, right? But the connector only have 7 wires. So what we're going to have, and we're going to have a shared grounds and powers or whatever, not here. So on this one, I'll tell you what is shared. The earth is shared between everything, pretty much. Earth is shared between there, airflow sensor, temperature sensor, and also our barrel sensors. The earth going to be a shared earth. Now, the 5-volt reference for temperature sensor cannot be shared, right? Externally. They cannot be shared. So 5 volts going to be on its own, stand alone, right? Because it's a temperature sensor. You cannot share temperature sensor 5 volt. You can, however, share the pressure sensor 5 volt to others with other sensors. That's no problem because this 5 volt is just the power supply for the sensor. But the temperature 5 volt is not only just the power supply, it also is a signal as well. So you cannot share the signal with other sensors, right? So this is what we're gonna see. So let's go and check the airflow sensor and do some testing. I believe if there's any question on the everything I wrote on the board here, just let me know any questions so far. So I'll just let you guys see that whiteboard and just get a quick grasp of everything we just discussed about. If you have any confusion, any question, just let me know and maybe I can shed some light on it. I'll put that wiring diagram there as well so you can kind of do your comparison and everything. Matt, Ruben, Josh, any questions so far? All right, looks like everyone understanding what I'm saying here, right? No question, Joshua. Good, that's good. Okay, let's move on. Let's move on to our testing now. Let's go to the car, and we got a wiring diagram here. So let's just quickly see what we can do. So on the board, right, we discussed that my red and my black here is power and earth supply, and the earth is shared between the sensors. All three of them sensors gonna share that earth, right? And then one is going to be my signal for the temperature sensor, intake air temperature sensor. More than likely it's that red and the blue wire. Then we're gonna have a signal for the barrel sensor, and then we're also gonna have a 5-volt power supply for the barrel pressure sensor as well. So let's see if we can figure that out here. So possibly this green with the yellow going to be my 5-volt power supply for the pressure sensor, because it is shared between pressure sensor and throttle position sensor. So 5-volt can be shared on a pressure sensors and the throttle position sensor. So more than likely number one, which is green and yellow, going to be my 5-volt reference for the pressure sensor. The ground is shared, right? And then one of this wire, so maybe the green, maybe the W, yes, so white, black, number 3, or my green, white, going to be my signal for the pressure sensor. So see, the white, black goes straight to the computer. It's not sharing with anything. We got green, white goes straight to the computer as well, not sharing with anything. And also my green one goes straight to the computer, not sharing with anything. So one of them could be our signal for the barrel, and one of them also is a signal for my airflow sensor as well. Okay, that's how it's gonna go here. All right, let's do some testing on the connector. Okay, so let's do our testing. The red wire. So number 4 pin red wire on this connector is my power supply, right? So make sure the key is on. I'm pretty sure my key is on the car. So I'm connected to battery positive. So when I find my power, this test light is gonna light up, right? So let's go number 3. Looks like starting from this way. Okay, so my 4th wire, number 4, is my power supply, which we have here. So test light is lighting up. No problem. Power supply is solid. Okay, let's check our earth. So battery positive, test light to battery positive, find the ground, the test light will light up. So we got The black wire, which is my 1, 2, 3. Sorry. 1, 2, 3, 4. The fourth one, the red one, is my power supply. The fifth one, black, is my earth. Okay, so let's find the earth. And there we have it. We got earth in that pin, as you can see. My test light is lighting up. So the power on earth for our sensor is good. Right? Now, we still need to eliminate, because there's so many wires, so it could be a little bit confusing here. So let's verify our 5-volt for temperature sensor, the intake air temperature sensor. Okay, like I said, the ground is shared between everything. So let's find that temperature sensor wire, which one could be. Now, in this sensor, there could be 2 or 3, depending on design, 2 or 3, one for the temperature sensor, one for the pressure sensor. We're going to see 5 volts, right? So on a temperature sensor, we're going to need earth and we're going to need power. So let's find that power. We know the ground is shared. So I'll just grab my multimeter maybe for this one, or we can use a scope. Just for easy testing, we'll just probably use the multimeter. All right, so let's connect my multimeter to battery negative. So my black lead to battery negative, and my positive lead, we're going to find that 5-volt, okay? So I'll just get rid of this wiring diagram for a minute. You can see the screen. Can everyone see the multimeter? Might be a little bit of glare. Just let me know if you can't see it properly. Okay. So let's test our multimeter. I'm connected to battery positive. We can see it's 12 volt. My multimeter is working. So let's find that 5-volt here. So we say we're going to have 2 5-volts. So let's start from the very first. The first one is a green with the yellow wire. So we got 5-volt on that. Nothing. We got another 5-volt there again. So we got 5-volt on the green yellow wire. We got 5-volt on my white with the black wire. And we got 4.7 volt on my red with the blue wire. Okay, so we got 3 5s here, if you round it up, right? So we got the first one, 5-volt. We got the third wire, another 5-volt. And we got the second last wire, which is red and blue. We got 4.7 volt. Can someone tell me which one is my coolant temperature 5-volt out of all 3 of them? Without looking at the diagram, without knowing everything circuit-wise, can you tell me exactly which one is my coolant temperature signal going to be? Okay, I'll repeat again. So we got a green-yellow wire 5-volt, we got a white-black wire 5-volt, and we got red, blue wire, 4.7 volt, rounded up to 5 volt. Let's say all three 5 volts. Which one going to be my temperature sensor? Can anyone tell me? Which one is going to be my temperature sensor 5 volt? Green, yellow. Okay, let's hear from others. Green, yellow. Okay. So in my understanding, the 4.7 volt is going to be my temperature sensor 5 volt, okay? Then the reason why I think the 4.7 volt is my temperature sensor is, I'll show you on the board why it is. So let me grab that wire again. So we got 4.7 volt, right? On that green wire. Sorry, not the green wire, the red with the black wire, red with blue wire. The 4.7 volt one you can see on the screen, that is going to be my temperature signal. Okay, so the reason, I'll show you on the board, but before that, we can do one more thing to verify this. Okay. Can everyone see my scan tool on the screen good? Can you read the numbers and everything on the scan tool on the screen? Can everyone can see the numbers of my scan tool? Good or not? The measurement numbers and all the writings there. Because this is a little bit critical. I need to show this to make you understand what I'm doing here. Joshua said 4.7 red blue. That's correct in my opinion, and I'm gonna just prove it to you in a minute. But I just need to know if you guys can see my scan tool, all my live data numbers correctly and clear, because I need to show this. Not too well. How about now? All right. I might just do something quickly so we don't miss this. So now what you want to do is you're going to connect your test light to battery negative, right? Connect the test light to battery negative. Find your earth. When you find your power. When you find the power, the test light is going to light up if you got your connection right. So on the tip of my test light, I got earth coming in through the test light, okay, from the battery negative. Now, what I'm going to do is, on the same wire, we suspect that it could be for our temperature sensor, the red with the blue, right? Let me just go there. So red with the blue. So I'm just going to sort of hold it without damaging the terminals on the red blue wire, which is number 6 pin on this sensor connector. I got earth coming onto the tip of my test light. So what I'm going to do, you watch this voltage on the multimeter. If you can see this voltage on the multimeter, 4.7. When the circuit is open, it's 5 volt. Let's round it up to 5 volt. And I'm going to touch that pin with my test light. Got negative on the test light tip. That voltage is going to drop to almost nothing, almost 0, right? Okay, what we're doing is we're pulling all that signal voltage down to ground. That's what we're doing here. So I'm just going to go and find my temperature sensor on my scan tool now. So ECT, not ECT, sorry, IAT, intake air temperature sensor. So when it's open circuit, it's going to be minus 57 degree on this car anyway. So it is a ridiculous number, unrealistic, right? Minus 57, because at the moment the computer is seeing open circuit, which is 5 volt. Computer is seeing 5 volt at the moment, which means minus 57 degree. So now what I'm going to do is I'm going to touch that same wire, same setup with the test light connected to battery negative, and you'll watch that temperature. See, my temperature went from minus 57 to 179 degrees Celsius, ridiculous number for the engine anyway. So what I'm doing is I'm pulling that 5 volt down to 0, down to almost 0. So that's what computer is seeing. So I can change that temperature reading on the scan tool just using test light. So that's how we can verify that that is my temperature signal wire, the 5 volt we're seeing. So if everyone got that, I'll try it again. I don't know how good my scan tool's coming up on the screen. We got 4.7 volt when there is open circuits. The connector is open, right? If I touch that wire with the battery negative connected to my test light, I got negative on the test light. That voltage dropped to 0 on the multimeter, you can see, and my scan tool reading a very, very high number. So that way we know this is my temperature sensor signal, okay? Now let's go to the board and I'll tell you why there is 5, 5, and 4.7. We saw 5, 5, and 4.7. So round it up to 5, all of them, and we say which one is our temperature sensor signal, right? And then we identify the Y, we identify the proper signal circuit here. Now I'm going to take it to the board and I'm going to see why there is not 5 volt. There's less voltage than the other 5 volts that we were expecting, right? DJ, thanks for joining in. Thank you so much for joining. All right, let's talk about that. I'm going to go to the board now. So the reason the 5 volt reference we talk about, which is also the signal as well for the temperature sensor, the reason we're only seeing 4.7 voltage there, I need to draw the picture for the coolant temperature sensor. So we got engine computer ECU, right? So 2 wires for the temperature sensor. This is just the ground. And in this case, the ground is shared between other sensors. So let's not worry about drawing it inside the computer. So let's say the ground comes directly from other source somewhere else. We don't care. And this goes to my temperature sensor like that. So we said this is our 5-volt signal wire or reference voltage, but we were seeing only 4.7 volt on this wire. The reason that is because there's a resistor in the computer before it travels that 5 volt down to that sensor. So if everyone's following me, 5 volt inside the ECU, traveling through a resistor, another resistor, and to the ground. So where does the computer do its measurement? Right here. Right here, its computer is going to do our measurement between two resistors. You can go and watch my coolant temperature videos. I'll show you in detail. This is the reason why that 5 volt coming from the ECU is dropped down a little bit. That's why we were seeing 4.7. So just by looking at that voltage, we already know which one out of all 7 wires is our coolant temperature sensor. Hopefully everyone followed that. So Ruben, Matt, everyone followed what I just discussed. The reason we are seeing 4.7 volt there is because the resistor, and it needs that resistor to make the temperature sensor circuit work, right? Okay, Matt's following. Thank you. That's good. Okay, let's move on to my other sensor now, which is our baro sensor. So we said on the baro sensor, we need 5 volt, ground, and signal. Right? So we still have 2 more 5 volts on that signal, on that connector, right? So we don't know which one is going to be our 5 volt for the baro sensor. We're going to have a ground, which is a shared ground between all the sensors. No problem there. We already verified our ground on that black wire. And the signal or bias voltage is going to be another 5, and some sensors don't have 5, so it's going to be 0. And I know this sensor is not going to have that 5 volt bias. So let me draw a picture real quick here before we go in there and we can understand a little bit better. Okay, so what we're going to have here on the baro sensor, same thing. Let's draw a computer. So we got the ECU, right? And then we're going to have 3 wires. This is a typical pressure sensor. We're going to have 3 wires coming out. Okay. So let's say this box is my pressure sensor. In this case, it's a barometric pressure sensor. Okay. Now, what we're going to have here is we're going to have a 5 volt. We're going to have a ground, right? And we're going to have a signal. So usually when the circuit is open, connected, disconnected, you're going to see 5 signal, ground. Okay? So in this sensor, we're not going to have a bias voltage. So sometimes they have bias, sometimes they don't have bias. And I'll show you what I mean by that. So we got a 5 volt source sending the power to the pressure sensor. We're going to have a ground, straight to the ground inside the computer, whatnot. And we're going to have a bias where the computer is going to do its testing, reading, not testing, reading of the voltage change. That's how the computer notes the pressure. So let's say this is our voltmeter, right? So what we're going to have is, in this scenario, we're not going to have bias voltage, means the circuit's going to look like this inside the computer. But the ones that has 5 volts going to have a resistor traveling down from the 5 volt to the signal sensor. So that 5 volts not only going to travel to the power supply 5 volt reference, it's also going to travel on the signal bias. That's why when the circuit is open, you're going to see a 5 volt here as well. The 5 volt doesn't do anything. It's just there for monitoring. The computer can monitor the circuit, the wiring, and everything. So in this case, we're not going to have that resistor. So that's why you're going to see 5, probably close to 0 and 0. So 5, 0, 0. That's what we're going to see. 5, 0, 0. So now we still have 2 more 5 volt we saw on that wiring. One of them going to be a reference for my barrel, and another 5 volts probably going to be a bias voltage for my airflow sensor. Okay, let's go and do some testing now. Can you test the 2 other 5 volt wires and get a dim light on the test light? Depend on the test light, it may not light up, but I can do that for you, no problem, Josh. So we want to do battery negative, and you're going to look for 5 volt. Is that what you're saying, Josh? I believe so. So we said the first wire and the third wire, the green, yellow, and the white, black is my 5 volt. We already verified our green with the blue for the temperature, so let's not worry about that. All right, I'm going to put on my first wire, the green with the yellow. My test light is not lighting up. The third one, white, black wire, and my test light also not lighting up. So I don't think this test light is capable of reading 5 volts. And on the test light, it does says it goes from 6 volt to 24 volt. So it might not work. Is that what you wanted me to do, Josh? Anything else you wanted me to do? Get a dim light on the test light. I didn't get any light on that test light, Josh. I don't think it's rated for 5 volts. Is it safe to use? DJ has a question. Is it safe to use that high amp draw test light in company to using a LED light one, so it doesn't harm the computer ECU? Okay, I see what your question is. So you're asking me, can we use a test light like I just did on that 5 volt wire, or do we need to use a LED light so it won't harm the ECU? I mean, I know there's a lot of talk about that on the internet. A lot of mechanic, they don't want to use the normal test light. You want to use the LED test light to do this type of testing. But I've done it many times. I don't think there's an issue as long as you are using a test light, because test light is going to have a resistor that's going to buffer all that voltage spike, high amps, and all that. So there's no problem. I've used it on all the time when I'm testing circuits like that. Obviously, do not put direct short. Don't put direct short jumper wire to 5 volts. But as long as you're using a test light and it has a resistor in it, I don't see a problem. Anyway, all right, let's move on to my barometric pressure sensor. So let's go here first. So on my wiring diagram, you can see, right? The black ones verified, the red ones power already verified. We got the blue with the black. It's red with the sorry for that. Red with the blue wire is my temperature sensor signal, right? So we verified that. Now we are left with 1, 2, 3, 4. 4 other wires. We still gotta check it out, right? So on the green, yellow, we saw 5 volt. We also saw 5 volt on the white, black. So these two has 5 volts. Okay, so let's go back there and let's verify exactly which one is my barometric pressure sensor 5 volt. You need to use a high amp test light, and yes, it is. You need to use high amp test light, and yes, it is safe. Yes, it is safe. I've never damaged anything in my whole career as a mechanic, testing electronics and all that. So it is definitely safe, Josh. Yes, thank you for that, Josh. That's possibly the response for DJ. Okay, let's do the testing. All right, I'll turn that multimeter on again so everyone can see. I hope. Okay, so we got 5 on that wire, and we got 5 on that third wire on the white. So they're both on the same level, 5.02 and a 5.02. So the way we can quickly verify is this. If it's because we're only going to need one 5-volt for the barometric pressure sensor reference, right? The other 5-volt is still present there, but I believe that's the signal for my airflow sensor. So now let's verify which one is my reference, which one is my bias. Then we can know what's going on here. So for that one, I'm going to back probe it on that first wire, which is my green, yellow, right? So we got 5-volt on the meter. I'm going to plug it in. Plugged in, nothing changed, still 5-volt. Okay, let's try the same thing on the white black wire there. White with a black wire. I'm just going to get a good connection here. All right, we got 5-volt again. Now I'm going to plug it in. See that 5-volt dropped to 2.6, 2.5. Right, it's jumping around. Let me see if my connection is true here. See, it's jumping around. Let me disconnect it. Back to 5-volt. So what does that tell us already? We know that this 5-volt that we are testing right now on a white black wire is a bias voltage. It's not a reference 5-volt power supply. So that, and I told you already that this barometric pressure sensor doesn't have a bias voltage. So that cannot be for our pressure sensor. So the other 5-volt, the first one we're testing, which doesn't drop, let me try again. Green with a yellow, back probe it, got 5-volt, plug it in, doesn't drop. So that's my solid 5-volt reference. That's what we want to see. So that's a power supply for my pressure sensor. LED will lie to you, definitely LED. I don't like to use LED on a lot of applications, a lot of testing. LED can definitely lie to you. Okay, let's go to my board. So we already discussed here, we found our 5-volt, right? So we found my barometric pressure sensor 5-volt, which is my green, yellow wire, the first one. The ground is shared between all the sensors, so we already know which one is our ground, the black wire, right? Now let's go find the signal. And I told you there's no bias voltage, so you're probably going to see 0 or close to 0. There's no other 5-volts left there on my connector on 7 wires. So that other 5-volts possibly going to be for my airflow sensor. So this is my AFS, airflow sensor. All right, let's go back there and let's see what can we find. Okay, so usually, this is another trick we can use. Usually, when you're looking at the connector like this, bunch of wires going into it, and we know the component has multiple sensors in it. Usually, the wires are close to each other. So for one sensor, let's say for an air temperature sensor, the wires were far to this side here. We already verified the 5-volt. The first wire on this side, green one with the yellow, is a power supply for my pressure sensor. So right next to it, I got another green with the white wire. If you can see on the camera, hopefully. The green with the white wire right next to it, the second pin on the wiring diagram, number 2. Usually they are next to each other for one sensor. Okay, you can try that. I've found that in many different sensors. When there is few sensor on the same component, one box, let's say, usually the wiring is arranged like that, close to each other for one type of sensor, then move on to the another type of sensor. So I'm pretty sure the second wire is going to be my signal. So let's just touch that wire and see what we see. So we got 0, 0, 0.016, which is close to 0. That 0 could be Earth, right? So let's just quickly verify that, if it's Earth or not. So I'm going to connect my battery test light to battery positive, and I'm going to look for Earth. So when I look for Earth, battery negative, the test light is going to light up. So let's see if that 0 volt we're seeing on the test light is not another Earth. Okay, so on the second wire, green, white, I got no Earth. So nothing's happening here, right? I'm looking for Earth. So we know that's not an Earth. That's actually 0 volt, means nothing. There's nothing in that wire. So like we discussed on the board, this pressure sensor has no bias voltage. So I will say that is our wire for my pressure sensor signal. Okay. So let's back probe it. On that wire. So we found the 5 volt, we found the Earth, which is shared between everything. Now we think this is the signal wire. So let's go to our scan tool. And let's go and find our barometric pressure sensor. So let's just go baro sensor right there. So currently I'm seeing 0, nothing. All right, let me just graph that as well, just to make life a little bit easy. So currently I'm seeing 0. Can everyone see my scan tool on the screen? Can everyone read my numbers on the scan tool? Just say yes or no if you can read my numbers on the scan tool. Okay. DJ has another question. Josh, before that, Josh said, LED is very good for testing signal, in my opinion. Yes, you can definitely do a testing, a quick, dirty, rough testing on, let's say, very fast signal, like a crank sensor, cam sensor, possibly even your injector control, things like that, the Hall effect and all that. You can definitely do that. It doesn't give you the detail if the sense signal is good or not. It will tell you if there's signal or not, but is it good, not? We don't know, just using the LED light. You're gonna need a scope if you want the details. Another question from DJ. Can you have used your register wheel and change the register to test the unit? I know the test light is quick, but we'd like to see how the scan tool data reacts to the changes. I know the test light is quick, but yeah, 100%. That's the way to do it. If you wanna, change the signal to a certain voltage, definitely register are a great way to testing it. But today we're not worried about it on this particular case, because this guy is not here for that. It's coming. We are testing the airflow sensor. That's our goal. But along the way, I just want to quickly touch base on everything, because this sensor does have 3 different components in it. And yeah, register is a great way to do it, but a quick test with the test light will tell you exactly if it's the right wire, just to identify the wire. Is the circuits working? If the wiring is good, if the computer is responsive or not. So you can do that dirty, quick little test with the test light. Matt said yes. DJ said yeah. Okay, everyone can see my scan tool. That's good. Let's move on to it. This is my signal again. And we're not doing any difference here. Anything different here. Exactly same what we did on a temperature sensor, right? Before I do that, I'll quickly go to the board. And then I'll show you one thing real quick. So basically, we've verified our 5 volt. It is coming to the sensor. We verified our ground. It's shared. It's there. Now we're going to test the signal to identify the wires and all that. So this one doesn't have a bias voltage. That's why we saw 0 volt on that signal wire, which is green, white wire, okay? Now, what we're going to do, exactly same thing. We're going to see if we can energize that signal and make the computer read the voltage or change that data on the scan tool, exactly like we did on the temperature sensor. Okay, currently I'm seeing 0 kPa pressure on that barrel sensor, right? If I connect it, the barrel sensor goes to 94, which is where my area is. Obviously 94 kPa is pretty close. Around 100, roughly, you know, if you want to remember that number, barrel sensor should read around 100, 99, 100. It depends on the altitude, location of your area, where you're at. It's just the atmospheric barrel pressure, right? So we got 94 when it's connected. When I disconnect, it goes to 0, right? So that's already telling me that that signal is working. Everything is getting to this computer because the scan tool is reading that. Now we're trying to identify if this is the wire for the barrel or not. Okay, on the meter, you can see as soon as I connect it, that jumps to 3.7 volt. Disconnected, it goes to 0. All right, let's see. While it's connected, let's see if this is our wire for the barrel pressure sensor. Looking at the scan tool, right? Seeing 94, battery negative. My test light connected to battery negative. Same thing like we did on a temperature sensor. I'm going to touch that wire. See, that barrel pressure dropped to almost 0, almost 7. It's jumping up and down, but around 6, 9. And on the multimeter, you can see my voltage is 0.3. It dropped from 3 volts, 3.7 volts, which is 94 barrel kPa. Touch the signal wire with the test light connected to battery negative. I can drop that voltage on the multimeter. I can drop the signal on the scan tool. So we know that's our barrel signal. Pretty simple. But that's not what we're here for. There's nothing wrong with the temperature sensor. There's nothing wrong with the barrel. You can see on the scan tool they're reading just fine. Now let's move on to airflow sensor. All right, so far everyone's understanding everything. Any question? Any question, any concern? I'll let you think about it. I'll let you just review what we just discussed. I'll probably put that on the screen for you guys so you can see the wiring diagram again, which is this one we're looking at. And we discussed that this green white wire is my signal for the barrel, okay? So we covered the green, white, we covered red, we covered black, we covered the red, blue. Now we left with 2 wire. We also covered the green, yellow. So we left with 2 wire here, green and a white with the black. Okay, we left with 2 wires. Any question, concern before I move on to the airflow sensor? Just give me 30 seconds. I'll just go for a quick break. I'll be back. Just 30 seconds. No question, you are a good teacher. Thank you, John. Thank you so much. All right, it's almost last sensor left. So after we discuss this, we should close the session, I believe. All right, airflow sensor. On the board, you can see we got Earth at the very top, AFS. We got 12 volt, Earth, and a digital signal. So that's 3 wires going to be my airflow sensor. So we got the 12 volt, we got the Earth, we already verified red and the black wire, all right? Now, the signal wire could be the green one, right? It could be the green one. It could be the white with the black one. So let's go and verify that. Okay, let's go to the scope again. For this one, we're gonna need a scope. So I got the scope already set up here. We're just gonna go plus minus 20 volts scale for now. All right, I'll get the test light out the way. We can do the testing with the the multimeter, but it's not gonna be accurate. Like you might see voltages, might be able to sort of see if it is making signal or not, but a lot of the time it's not very good idea to use a multimeter to test airflow digital sensors like that. Okay, so I'll get that out the way. And let's connect our scope, channel 1, battery negative, my black lead on the battery negative, and my signal for my scope. I'm gonna go find those 2 leftover wires. So we got the white with the black and the solid green. Those are the 2 wires we still haven't verified and identified, okay? Okay, so let me go and touch the white with the black wire. Okay, I'll just change that camera angle real quick. Josh said no, all good. Thank you, Josh. Okay. Now on the white with the black wire, I'm just gonna touch it quickly, battery disconnected. On the scope, I'm seeing 5 volt. Before we were seeing 5 volt and we said it's a bias voltage for the airflow sensor, I believe. So let me back probe it. And we're gonna do this connected. So back probe that. And then let me bring up the screen quickly. And let's connect that. So we got 5 volt disconnected. Let me connect that. It dropped to almost 0 volt. On the scope, I don't think I have a good connection. Let me just find a good connection. All right, 5 volt. Now let's connect that. So as soon as I connect it, you can see, let me change the probe. It's not making a good contact. As soon as I connect it, you can see on the screen, it's got some digital signal happening, right? I'll just zoom it in a little bit more. So that's the signal we're seeing, digital. So it goes from 0 volt to 5 volts. So it's a 0.5 signal, digital signal, just like the Hall effect, cam angle, crank angle sensor, right? So this is a frequency type, hertz. So when the car is not running, just the ignition on, we're seeing some activities on that wire. So I know that is going to be my airflow sensor signal. Okay, so now we've identified the third wire. On the board again, red is the power supply for the sensor, black is the earth, and the signal is going to be my white with black trace, which is a digital signal as we're seeing on the screen. We can try green too, Josh, if you want, but I believe this is our signal wire. Let me try the green too if you want. That's no problem. All right, I'm going to go and connect that to green, which is my very last wire. Let me do it disconnected so we know what it looks like, connected and disconnected. All right, that's my green. I'm connected. I'm seeing nothing on the scope. I'm seeing nothing. Let's connect that. I'm still seeing nothing. Disconnect nothing, connect nothing. I'm seeing nothing on that green wire, so I do not believe that's an airflow sensor signal. It is definitely going to be my white with the black wire. Okay, this is going to be my signal. So on the wiring diagram, let's just quickly go and have a look. I just want you guys to understand everything. So I'm just taking my time. I'm doing it live, so it's going to be slow and steady, but we'll get there. So this one, white with the black, number 3, third wire on that connector is going to be my, and it goes to pin 90 on the ECU there. Okay, this is going to be my signal for airflow sensor. The green one, we'll talk about it after. Okay, there's one more thing on this sensor that we haven't discussed so far, but we'll discuss about that later. Let's just cover the airflow sensor signal and then we move on. Okay, I'm going to go back and connect that wire back to the white black wire. I'm not making a very good connection here, but let's see. Okay, there we go. We got a good connection now. So we got a digital signal happening on the screen. Now I'm going to go and start the car. Not only that, we can also check our scope, the screen on the scan tool, right? So we got 0 hertz at the moment, and on the scan tool you can see we got some activity happening. I'm going to go start the car now. Okay. On the scan tool, it went from 0 to 62, right? It went from 0 to 62 hertz. So we know the airflow sensor is working. The car is running just fine today. And if I rev the car, you'll see the scan tool, the hertz, the frequency will change, right? So I'm just going to reach out and rev the car a bit. You can see it goes up and down, 100, 400, whatever numbers were there. So as you're revving the car, more airflow means more frequency, more hertz on that one. So let's go back to the scope here, and you can see on the scope as well. we got a digital signal happening. So this is a digital 0 5 volt signal, just like the Hall effect. Any question so far? Does anyone have any concern, any questions so far? DJ, I hope you're still watching it. Matt, I haven't seen Ruben. I think Ruben disappeared from the chat. John, any questions so far? So this is what it's gonna look like when it's at idle. Okay, I'm gonna rev the car now and you'll see nothing changes amplitude-wise. The height of the sensor, 0 5 volt, right? So the height, so this height does not change. It stays at the same voltage level, but the frequency will change if I rev it, okay? So I'm revving the car up. You can see the frequency changes. The more you rev it, more RPM it's got, more airflow it's going into the engine. The frequency gonna be tighter. It's gonna be, the frequency is going to be tighter. The frequency gonna be higher, basically. So all right, I'm gonna try it again. Rev the car up. I'm just using the accelerator cable here. Just the frequency gonna be tighter. That's all is changing, right? Like I said, this sensor makes its own digital signal, okay? And then it sends to the ECU, and then ECU knows how much air is coming in and out, coming in through that airflow sensor, just seeing that frequency changes. And you can see the frequency changes on the scope, and you can see the frequency changes on the scan tool at the same time. Okay, do it again on the scan tool. On the scan tool, it will look like that. On the scope, it'll look like that, okay? All right, turn the car off. Joshua, okay, cool, thanks. Thank you, brother. Still here, just taking it in. No worries, DJ. DJ, have you ever run into an issue where the frequency drops out? What will you use to find the dropouts on the scope math channel? Exactly right, DJ. I was going to get to that now. So, like on the analog signal, let me go to the board quickly. Like on the analog signal, I'll just get rid of that real quick. On the analog signal, let's say we got 0 5 volt signal, right? On the scope, you're gonna see as you rev the car up, you're gonna see up. As you're coming down to idle, it's gonna settle down and go up and down as you're revving. This is the analog type. Analog type, right? Now on the digital type, you can't really see that changes other than the frequency changes. The voltage level doesn't change. So what we can do is we can use the math channel or we can use the frequency on the scope. So we can get the analog type signal, okay? So we can just change the same signal into frequency signal so we can tell if it's going up or down. Is the airflow sensor responding? Just by looking at that, square wave, we don't know. Is it good? Is it not good? We kind of can tell is coming in and out, like the signal is getting tighter and bigger, but that's all we can say. So what we can do is we can use a frequency channel. So we'll probably use that, and then we're gonna see a similar pattern as the analog signal. That way we know when the revs is high, signal is high, when the revs is down, signal is down. And you can also see those glitches. If there's an issue with the sensor, it's kind of working, but there's glitches. There's a bit of a problem there, right? Maybe the car has a hesitation when you're revving. Maybe sometimes the car act up, you know. There could be some glitches. It is making its signal, but it's kind of, you know, not at 100%. Sometimes it's dropping out, okay? So we can do that in now. Did you hit the airflow sensor to make the car run? I didn't hit it. I was just around that area. I just touched it. I didn't have to hit very hard. I just touched it, so it just, yeah, started working. Anyway, we can do the heat test, Josh. No problem. We can hit the sensor. Let's do that anyway. Let me go to the my signal. That probably is the best way to get the clear picture here. And we're gonna hit that sensor. Let's see if we can make a dropouts here. All right, that's my signal. I'm gonna reach out to the sensor and let me see if I can change the signal. I can hear the car is trying to, you know, stall or trying to do weird stuff there. I can hear the engine revs going changing as I'm hitting here. Okay. So make sure my connection is true. So I'll hold that connection so I don't bounce that connection around. So I'm just gonna hit it. You can see the dropouts on the scope. Okay, you can still see a little bit of changes there as I'm hitting. When it's working, everything is the same level. The frequency is the same. The voltage levels are same. But when I bang on it, you can see that changes. You can see that dropout right there. You can see that, right? So that's what I'm talking about. That's definitely the issue with this car. So let me go back and show you where the dropouts were when I was hitting the sensor. If I can catch it. I'm just going back on the scope. All right, right here you can see there's a bit of a dropouts there. Not only that, you can see right there too, there's a bit of a dropouts there as well. So yeah, you can absolutely check the dropouts like that. And there's no question about it. This sensor had some issue. That's why the car wasn't running right or stalling. Right, let me try again, one more time. There you go. You can definitely see that. And I can hear the engine trying to do weird stuff, the RPMs dropping and all that. Would love to see when it was stalling. I would say when it was stalling, it wasn't making any signal. That's my assumption there, Josh. I don't believe so. It just came back to life as well. You know, I was touching the sensor or bouncing it around, whatever I did. So definitely it needs a new mass airflow sensor. That's going to fix this car. Now let's do the frequency. Then we can make it kind of like an analog signal if you want to do that. Okay, so for that one, what we need to do here is simply we need to go to the scope and we're gonna drop this where this says DC voltage. There's AC, DC, and frequency. We're simply gonna hit the frequency like that on my Pico scope. I don't know the other scopes you're using may not give you that, but my Pico scope does give me that options to change it to frequency. And not only that, what I would like to also do here I'll just go and turn the key on. I'm going to grab my second channel. I'm simply going to just make a double connection, piggyback on that same channel 1 probe, the second channel, and I'm just going to find the earth for that second channel. So I got both the channel on the same wire. So we're going to see the digital signal and also the frequency. So that way we got both covered, okay? Now I'm going to reach out to my scope and I'm going to turn my channel B on, 20 volt scale. Okay, and I'm going to go and start the car. So my top, the blue channel is my frequency. So I just changed that to from DC, let's say. All right, that's my DC, wherever that went. See, both are same signal from the same connection. I'm just gonna simply change that to frequency. That's all I'm doing. So now we may have to change this hertz depending on the sensor, right? So, and that's my, let's go to a 2000 hertz. Okay, so that's my frequency, and that's the red channel is my digital signal. Okay, that's it. That's what we're seeing. Now I'm gonna reach out and rev the car, and you can see exactly the same pattern as the analog signal. I'm gonna reach out and I'm gonna rev the car now. You can see it's going up and down. You can see it's going up and down just like the analog signal. That way we know that the airflow sensor is responsive when you're revving the car. All right, I'm gonna do it again. Okay, so that's what it's going to look like if you change that to frequency. All I did is change the same signal into frequency right on the drop-down menu there. Now, follow this line where my cursor is. This is the frequency. And if you compare that to scan tool, the scan tool is going to exactly show you the same frequency as well. Right? So as I'm dropping to idle, as I'm revving, going up. So all these glitches, I don't know. I can't explain to you. It could be an issue with the sensor. That's why we're seeing that big spike everywhere. Like here, it's not a clean signal. You can see the spikes everywhere here. So that could be because our sensor is bad, it's failing, or is it just how it is? Because we're just converting the digital signal into a frequency signal. I do not know. I have tested it in the past, and you know, some cars I see a little bit of activity like that, big long spikes and dropouts, but the car still runs good. And some cars I've tested, they're very clean. You don't see any of the glitches like this. You see very clean up and down signal like that. So I do not know, is that a normal or not normal? I cannot explain that to you. So if you can zoom, if you want to zoom it in on the digital signal, you're still getting that same digital patterns there, like you can see, same digital patterns. So yeah, that's one way you can use to test a digital frequency type mass airflow sensor. All right, so what we got here on the chat? Let's see. We got DJ. I have opened them in the past and just used some compressed air to blow out the dust, and it worked. Unless there is a crack solder on the board, or if you tap it, it makes contact and works kind of. Yeah, that's pretty fundamental there. Maybe a solder, maybe dirty contacts. Who knows? But for us as a technician, we want to make money. We just want to change the sensor. If it's my own car, maybe I'll go to that extent. But if it's a customer's car, look, hey, we need to make money. I've done my diagnosis, and that way we know the problem's not going to happen again, right? John, are those high spikes in the frequency channel ignition noise? I do not think so, because they're not on a pattern. They're just kind of everywhere. So I don't believe it's ignition. But again, I have no answer for that. It could be just the sensor is failing. Okay, now let's move on to the last section on this one. The last one we're gonna do is the one leftover wire here. Okay, so that's what we're gonna do. So we talk about all the 6 wires. We identify everything, what it is and whatnot. But we still got one wire we haven't tested nothing on it, which is the last wire, the green. So we're looking at this one here. Green wire goes directly to the computer, pin number 19 in the computer. This green wire, pin number 7, the last one on the connector. So what that is, I'll tell you, it's an on-off, some kind of on-off switch. So Josh said, is that what the scan tool is doing for you like that? I believe that's what it is, Josh. I believe so. So on the scan tool, we got 2 airflow sensor data here. Let me come back again on the scan tool. It's a very slow communication, this one. Okay, on the scan tool, you can see there's VAF reset signal and VAF sensor. So there's 2 data for the airflow sensor. We're not worried about the hertz frequency sensor data because we already talked about that. We're just going to worry about the VAF reset signal. I'll just start the car and I'll show you what it quickly does. So right now it's on, right? So if I rev the car, I'm just going to reach out and rev the car. Off. Come back to idle, it's on. So if you rev the car, it goes off and on. So I think it's some kind of idle switch. When the car is at idle, it's on. When the car is at revving, it's off. So that's what it is going to be. My last wire, that green wire, is that one. I'm pretty sure. Let's see what kind of signal we get on that wire. Maybe in the future, someone wanna know about it, or let's just do it for fun anyway. So we're looking at the scan tool. I'm gonna go and I'm gonna put a multimeter on that wire, and let's see what happens. So my multimeter positive, battery negative. And we're gonna go to that number 7 on the connector, number 7 pin, the solid green wire. All right, we got 0.1 volt on the multimeter. Okay, 0.1 volt. So I'm just gonna, before that, I'll quickly bring the scan tool as well. Hopefully you guys can see that on the scan tool. We are seeing on at the moment. All right, we got on, VAF, airflow sensor reset signal on the green wire. We are seeing 0.1 volt, right? So let me rev the car. Scan tool shows off, and my multimeter shows 7.59 volt. 7.59 volt. Idle, 0.1 volt. Rev up, 7.6 volt. Okay, there's only two voltages here, 0 volt or 7.6 volt. That's all we have. That's the on and off signal, some kind of idle and revving situation. RPM on and off signal here. I don't know what it does. Maybe the computer wants to see that signal, or maybe computer sends that signal back to the airflow meter to do its job. I'm not sure. Obviously, computer can use that signal to operate other sensors and actuators. So let me do it again. 0.1 volt on idle, and the scan tool says on. Rev it. 7.6 volt. Scan tool says off. Doesn't matter what rev. It's just two voltages, 0 and 7.6. Okay, that's all we have on that green wire. Now, basically, that's pretty much it on this wire, I think, on this connector airflow sensor. That green wire on and off signal maybe possibly that so the computer can control the idle control motor, maybe to do the adjust the idle whatnot, but I don't have an answer for that. I didn't build it. I'm not the engineer. I'll just show you what I can see. All right, so far we covered everything on that airflow sensor, and like I said, this will apply to Triton, Pajero, Magna, Lancers. I have seen on multiple Mitsubishi vehicles. Exactly same looking sensor. I don't know, there may be variation. One could be of a different design than the others, but they all look the same and similar amount of wire on them. So any question, anything before we wrap up? Thank you guys for joining, though. I really appreciate it. I do enjoy doing this stuff, but sometimes, there's no one watching it, so I kind of, lose my inspiration. But yeah, but it was fun tonight. Everyone was watching it. There's how many people? 5 people on the chat, which is better than nothing, right? Can you try a probe the air seal to see if the signal gets cleaner? Can you try a probe that a seal to see? I didn't get that, Josh. What's can you say that again? I'm trying to understand what you're trying to say. DJ, thank you again for the training. I mean, yes, thank you so much. Thank you so much for joining. John, thank you very much. Thank you very much. Matt, thank you. Thank you, brother. And answering the question, learning all the way from Trinidad and Tobago. Trinidad and Tobago. I don't know what that means. Is it the name of your place where you belong, where you're from? I hope that's what you mean, Trinidad and Tobago. No problem, DJ, anytime. Thank you so much for watching. Josh has a question here. Can you try a probe the A seal to see if the signal gets cleaner? Okay. You want to see if the mass airflow sensor frequency gets cleaner. Okay, I see what you're saying. A shield. So what shield can we use here? Josh, do you have any idea? It's a country in the Caribbean. Love the Caribbean. Love the Caribbean. Thank you, DJ. Venezuela. They love the Caribbeans. Thank you so much, brother. I'll just answer Joshua's question before I wrap it up, if he still has. But I'm trying to see how we can seal that circuit. What can we use here, Josh? Do you have any idea? By the way, Josh is a fantastic mechanic himself as well. Josh do have a YouTube channel, don't you, Josh? If you want to put your YouTube channel on the comment, maybe DJ and John, everyone who's watching may wanna join your YouTube channel. If you're interested, Josh, you can I can give you a shout out there. Nathan, hello Nathan. Had a Lancer with the same stalling at idle, new airflow sensor. It would idle but had no power. Wrong AFS, but scan tool showed same hertz reading for both sensor. Definitely, like I said, they all look the same. There could be variation, and Nathan can testify that. Nathan just said he had the experience with it, so definitely there are variation. Doesn't mean they look the same, works the same. Okay, so that's another great tip there, Nathan. Thank you. Anyway, thank you so much, guys, for joining in. I'm just gonna close the video now. I'll see you next time. Hopefully, something else we can learn next time we have a car in for a diagnosis. If you want to learn about something specific, just drop a comment and I'll try to make a video regarding a particular topic you want me to discuss about, and we can learn together. Anyway, have a good night, guys. Be safe.